Hey class, in today's lesson we're going to talk about function operations, which is found in section 6-6 of your book. Alright, so our objectives are to add, subtract, multiply, and divide functions, and we're going to find the composition of two functions. So this is basically just letting you know what the function operations look like when they're set up. So the addition function would be f plus g of x equal to f of x plus g of x. If you're subtracting functions, you're literally subtracting whatever the first function is from the second, multiplying same, and division is the same. It goes on to say that the domains of sum, difference, product, and quotient consist of all of the x values that are in the domains of both f and g. So if you can find the domain of f and you can find the domain of g, then it's all of it together. Also, the domain the quotient function does not contain the x values for which g is equal to 0. So basically, the domain is all numbers except for where the denominator would be set equal to 0. All right, so we're just going to practice adding and subtracting. So f plus g. So literally, f plus g of x would be f of x. I'm going to write it first, f of x plus g of x. So that would be 4x plus 7. And I'm putting this in parentheses as practice. And g of x is the square root of x plus x. Now, since it's addition, we don't really have to worry about anything except for literally combining like terms. So our answer would be, if you combine like terms, and I'm not really picky here about an order, but let's go ahead and say that it's 5x plus 7 plus the square root of x. Again, I don't really care the order, just as long as you have them there. Okay, then f of x, or f minus g of x, is basically f of x minus g of x. So that will look like 4x plus 7 minus the square root of x plus x. Now, it's important when you use subtraction to go ahead and put it in parentheses so you can distribute to both. So this is really 4x plus 7 minus the square root of x minus x. Then when you combine those like terms, 4x minus x is 3x plus 7 minus the square root of x. All right, let's try the next one. So again, we're doing f of x plus g of x. So f plus g of x. I won't write what the rule is again, but that would be 2x squared plus 8 plus x minus 3. If we put them in standard form, that would be 2x squared plus x plus 5. Okay, g plus f of x. Nope, that's not what it says. Sorry. It says f minus g of x. F minus g of x is going to equal, in parentheses, 2x squared plus 8 minus x minus 3. And again, when subtraction, you put in parentheses so that you can distribute to both. So that'd be 2x squared plus 8 minus x plus 3, which would give you 2x squared minus x plus 11 as a final answer. All right, let's keep working. So in example 2, we're going to perform the following operations. So f times g and f divided by g. So again, f times g of x is really f of x times g of x. So f of x would be x squared minus 9. G of x is x plus 3. Remember, when you multiply polynomials, you should really use the box, better known as basically your distributive property. It's your choice, it doesn't matter. So this box will be x cubed, 3x squared, negative 9x, and negative 27. When you take everything out, your final answer will be x cubed plus 3x squared minus 9x minus 27. All right, f divided by g. So f divided by g of x equals f of x divided by g of x. Now, f of x is going to be x squared minus 9 over x plus 3. Now, in order to do this, this is basically back to rational functions, okay? So we need to factor the numerator because the denominator is in simplified form. So the numerator you need to recognize is difference of squares. So that'd be x plus 3 and x minus 3 over x plus 3. Okay, they both share x plus 3 in common, so your final answer is x minus 3. Let's try the next one. So again, we're multiplying. This time I won't write the rules. So this is f times g of x, which would be 3x squared minus 11x minus 4 times 3x plus 1. Let's go ahead and do a box for that. So 3x squared, negative 11x, negative 4, and then we got 3x and 1. So this is going to be 9x cubed, 3x squared, negative 33x squared, negative 11x, negative 12x, and negative 4. When I take everything out of the box, our final answer is going to be 9x cubed minus 30x squared minus 23x minus 4. All right, when we divide f over g of x, that would be 3x squared minus 11x minus 4 over 3x plus 1. Now the denominator looks like it's factored as far as it can go, but the numerator we need to do AC just to be sure. So AC would be negative 12. The factors of negative 12 are 1 and 12, 2 and 6, 3 and 4. The only ones that are going to give us negative 11 are 1 and 12. Specifically, it'd be negative 12 and positive 1. So that'd be 3x squared plus x minus 12x minus 4. If I group, I can take x out of the first and we'd be left with 3x plus 1. If I take a negative 4 out of the other one, I'd have also 3x plus 1. So really the numerator should be 3x plus 1 and x minus 4 over the original denominator, which is 3x plus 1. The 3x plus 1s will cancel, so our final answer will be x minus 4. All right, so composition, one of my favorite parts of dealing with functions is it says the composition of a function g with function f is written as g of f and is defined as g of f of x equals g of f of x. Essentially what that means is just like how you go back to evaluating, or maybe you had like f of 3, you would put 3 into the f function. So what this is saying is you would put the f function into the g function wherever x is located. So it says the domain of g of f consists of the x values in the domain of f for which f of x is the domain of g. So we would first evaluate what the innermost function is, and then you would substitute whatever that answer in for g. Okay, so let's practice. All right, so if you looked at the last screen, really this is not written correctly, but there wasn't a little circle to be able to write this correctly. So really the function should look like g of f, and there's a little o, g of f of negative 3, or it can look like g of f of negative 3. They're all the same thing, okay? But either way, what this means is you work backwards. So you put negative 3 into f, and then whatever answer you get there, you put it into then g. So let's do that. We have negative 3 that needs to go into f. So right now this is going to be f of negative 3. And that would equal, wherever x is where I'm going to substitute negative 3. So it's going to be negative 3 minus 5, which is negative 8. Now I'm then going to take that negative 8 and substitute it into g. So that would be negative 8 squared, which is 64. So 64 is our final answer. Okay, let's practice one more. All right, so f was x minus 5, g of x is x squared. Okay, it says perform the following operation based on example 3's functions. All right, so let's go back and look at what f was and what g. So remember, f of x is x minus 5. And if I just wrote that wrong, oh well, we'll just go with it. All right, so what this is telling us is that we need to put negative 3 into g, and then whatever answer we get there, we're going to put into f. Okay, so let's do that. Negative 3 into g would be negative 3 squared. Whenever you substitute, always put in parentheses. So we get 9 from that problem. Then we need to take that 9 and we need to put it into f. So this would be 9 minus 5, which equals 4. So 4 would be our final answer. All right, guys, they do get a lot more complicated than this. So if you have any questions about your homework or anything about this lesson, please come see me for tutoring.